Hi! In this video we're going to continue our look at Python optimizations, and in particular we're going to look at peephole optimizations, which is just another variety of optimizations that happens. Now these happen at compile time, and of course your Python code gets compiled before it can run, right? It doesn't get pre-compiled the way a typical, C language, for example, might get compiled into an executable, once it gets linked. This occurs as it's running, but it does compile your code, and it doesn't have to recompile the same bit of code every time that that code runs within the scope, within the context of running your application. Every time you restart your application, it may recompile. But as long as your application is running, once it's compiled a piece of code, it's going to keep using that compiled version of the code. So certain things get optimized. For example, constant expressions. And what I mean by that is, let's say you have a piece of code that assigns this value to a variable, a equals 24 times 60. Now, if that line of code gets executed many times during the lifetime of your program, well, it's going to have to calculate 24 times 60 again and again and again. So you might think as a developer, well, heck, if it's going to do that, I'm just going to put the value 1440 in there. But let's say that, your line of code was minutes equals 24 times 60. Well, now, if you read that from a readability standpoint, it's easy to understand that, okay, well, this means the number of minutes in a day, right? 24 hours times 60 minutes. But if you were to store, if you were to say minutes equals 1440, it might not be immediately evident that this is the number of minutes in a day. So it would be better if you could just leave 24 times 60. But for optimization reasons, if this line of code is going to run thousands of times, then you may say, well, I'm going to store 1440. I'm going to write 1440 in there. But in fact, you don't have to do that. Python will actually do that for us. So we can leave our code as 24 times 60, but when Python compiles this line of code, it's actually going to replace it with 1440. It's going to calculate it. Why? Well, this is a constant expression, so it's safe to do that. As your program is running, this line of code, 24 times 60, isn't going to change. It's essentially a constant. And so constant expressions, or expressions that evaluate to a constant, get pre-calculated and stored. Also short sequences. Short sequences, length less than 20, so sequence types, things like lists, tuples, and strings, will also get pre-calculated. So for example, this tuple, 1, 2 times 5, which evaluates to this long tuple here, well, that's less than 20 in length, and so that is also going to get pre-calculated and stored. Same thing with ABC times 3, that evaluates to ABC, ABC, ABC. Again, these are all constants, and it's going to get pre-calculated and stored. Same thing with this one, hello plus world, that is also a constant. Okay, it's a constant string. It's also less than 20 characters, and that will also get pre-calculated and stored. So every time those lines run, it will use the pre-calculated values. It will not rerun or reevaluate the expressions. On the other hand, the quick brown fox times 10, well, that is more than 20 characters, so that will not get stored, right? There's a trade-off between, storage and computation. So how much overhead do you want to have by storing pre-calculated expressions versus the speed? And so Python decides to do the trade-off at 20 characters. Okay, the next type of peephole optimization we'll look at is membership tests. And what I mean by membership test is something like this. If E in this list 1, 2, 3. Now, this list is actually a constant. Yes, lists are mutable, but in this case, this is, your code. This is the string in your code. Well, that is not going to change as your program is running. You don't change, your actual Python code as the code is running. So this is actually a constant expression. Now, if you had like variable names in here instead, that would no longer apply because the variable's values could change, and therefore, this list expression's evaluation could change. So that doesn't apply. But here, this is just a constant. So, when that is encountered, then Python is going to replace the constant mutable expression by its immutable counterpart. So for example, it will transform essentially the list 1, 2, 3 into the tuple 1, 2, 3, which is a little more efficient for membership testing than lists. So lists will get converted to tuples, and sets will get converted to frozen sets, which are the immutable counterpart of sets. And we'll look at sets and frozen sets and lists and tuples in a lot more detail later on in this course. And we're also going to look at this replacement in code just now, just a little later in this video, and that might make a little more sense as to what's happening. But before we do that, I want to talk about set membership. Set membership is much faster than list or tuple membership because sets are basically dictionaries, right? It may not look like it, but sets are basically implemented just like dictionaries are implemented in Python. So it is much faster to do a lookup of a dictionary, right? If I want to see is, if E in the set 1, 2, 3, I want to see if something is in the set, it's a dictionary lookup. But when it's in a list or a tuple, you essentially have to sequentially move through until you find what you're looking for or you don't find it. Okay, so much easier using, kind of hash maps than using lists for membership testing. So if you are ever in a situation in your code where you're writing something like if E in this constant list or this constant tuple, then you should really think hard and probably write it this way. If E in the set 1, 2, 3. Now, if it's a line of code that's going to get executed once and the list is short, yeah, it doesn't really matter. But, if this is code that's going to get executed again and again and again and again, really start thinking about maybe using sets for membership, especially with constant expressions, instead of lists or tuples. So it is more efficient, and we'll look at that in code. And we'll do that right now. So let's start by looking at some of the Peephole optimizations with constant expressions. So we'll create a function, let's call it myfunc. And first thing, we'll set a equal to, let's say, 24 times 60. Then we'll do b, we'll make that a tuple that's repeated, so times 5, right? So that's going to be the tuple 1, 2, 1, 2, 1, 2, 5 times. So that will be 10 elements. Then we'll say C is equal to some string, let's say ABC times 3. Then we'll do another string, we'll do AB times 11. So this is now going to be a string that will be 22 characters long. So that should not get pre-calculated and stored because that is more than 20 characters. And we can look also at another string if you want, the quick brown fox, and we'll do that times 5, let's say. And lastly, we'll look at, let's say, a list containing, maybe A and B, 2 strings, and we'll multiply that by 3. So this will be a list with 6 elements in that list. However, a list is mutable. It's not a constant technically. So that list is not constant. So that also is not going to get calculated. Okay, so we executed that block of code, which means that Python went through and actually compiled it. So now we can look at what are the constants that are associated with that function. So to do that, we can look at this kind of arcane piece of code, and we'll get back into these kinds of expressions when we look at object-oriented programming with the double underscores, and we'll see a lot more functions that have double underscores as well as properties and so on. So in this case, we're looking at this property that contains all the constants that are associated with that function now that it's been compiled. So when we do that, you'll notice that we have, 24, 60, 1, 2, all these are numbers, right, in that code. They're all present. That string ABC is here, the string AB is here. But take a look at 1, 2 times 5. It's actually this right here. So that was pre-calculated, right? The 24 times 60, which is 1440, is right here. So that was pre-calculated as well. You'll find AB and you'll find 11, but you're not going to find AB 11 times because that's too long. So it did not get pre-calculated. Same thing with E. You'll find the quick brown fox is present, but not the quick brown fox 5 times. And then the same thing with the list. It also is not pre-calculated as A, B, A, B, A, B, because that is not a constant expression, right? A list is a mutable object and therefore it's not constant, so Python isn't going to pre-calculate it. Okay, so the next thing we're going to look at is the membership tests. Okay, so what I mean by the membership tests, remember, was using the in operator. So we can go ahead and we can look at myfunc and we'll pass in, let's say, E, which is going to be the element we want to search for. And if E in, and we'll use the list 1, 2, 3, and then we'll pass. We're not actually going to do anything with it. And we'll run that piece of code. So that function now has been compiled. And we can go ahead and pull up the constants that are associated with that function. And you'll notice that with this membership testing, the list 1, 2, 3 became the tuple 1, 2, 3. So remember, when we do list and sequence memberships, basically, then the Peephole optimizer is going to transform any kind of mutable element into an immutable version of that element when it can. So in particular, lists become tuples. And if we were to do the same thing again, but this time we'll use a set. So we'll use the set 1, 2, 3. Then when we look at the associated constants, you'll see that the set 1, 2, 3 has become the frozen set 1, 2, 3. Again, we'll look at sets and frozen sets in a lot of detail in a later section. Okay. So the last thing that I want to do is kind of a quick and dirty benchmark, if we can call it that. I mean, benchmarks are more complicated. You have to take averages, run multiple times, and so on. We're just going to do some basic timings, basically, on set membership versus, let's say, list membership or tuple membership. And remember what I said in the slides a little earlier, but set membership is very much more efficient than searching inside a list or a tuple or a string for that matter. Okay, so let's take a look at how we're going to do that. Well, we're going to import the string library. We're going to get something out of the string library that I'll show you in a second. We're going to import the time library. We need to do timings. Okay, so let's import those two libraries. Then I want to show you that the string library has some constants that are pre-created for us, like ASCII letters. So if we look at that, it's basically a string, which remember is a sequence type, that contains all the ASCII characters, lowercase and uppercase, in that order, right? So what we're going to do here is we're going to create a few variables. We're going to create one, which is going to be a list, and that list is going to contain the ASCII letters. Then we're going to create a tuple in the same way. We're going to create a tuple and we're going to create it using the ASCII letters. Now you'll notice that this is I'm using the constructor for the list. The list has multiple constructors, one of which it can handle basically strings. And a string is just a sequence type. But what it does when you pass it inside the constructor, it takes every character in the string and makes it an element of the list. And then same thing with tuple, which is just the immutable version of a list. Now, we can also do that with a set. So we can call the constructor for the set, passing in also this string. Now, we'll look at sets in a lot more detail later. But for now, basically the set constructor is going to do the same thing. It's going to take this sequence of characters and it's going to create a set out of those characters. If there were repeating characters, it would ignore them because sets do not contain repeating characters. Okay, so we've now got each one of those. Let's take a look at what they look like. So the list is basically just the list, right? Let me use the print statement so that will be a little more concise. Okay, so we have the list, then we have the tuple. Okay, so the tuple, it's basically exactly the same, and you'll notice that the order of the elements in the list and in the tuple are basically the same as the order that we had in that string right here, right? It maintains the order, and that's because lists and tuples are ordered sequences. On the other hand, set is not an ordered sequence. So if we look at set, you'll notice that yes, we have a set, but there's no guarantee on the ordering of the elements inside that set. All the elements are there, not repeated, which they weren't anyway in this case, but they're not repeated, but they're in no particular order, just like a dictionary. Okay, so the next thing we want to do is we want to basically run a test, and we want to time that test where we're going to look for a character inside the list and the tuple and the set, and we want to see how long it takes to do that. So we're going to write this method. Let's call it membership test, and we're going to pass in n, which is going to be the number of times we want to test for membership, because obviously it goes so fast that if we were just to try and time a single membership test, we wouldn't be able to tell the difference, right? So we're going to just repeat that test many times. And then we're also going to pass in the container, which is going to be what do we want to search? Well, what object do we want to search? And we'll hard code the object that we're searching for, the string that we're searching for. So for I in range n, right, we're going to repeat this test n times, and we're going to say if, and let's pick some letter in here. Maybe we'll pick P. All right, so let's look for P. Actually, maybe let's pick something more in the middle. Let's go with lowercase z. Okay, so if z is in the container, okay, so we're going to look at whatever that container is, and the container could be a string, it could be a list, it could be a tuple, it could be a set, it could be a frozen set. This operator will figure out how to find something in that particular container. And that's one thing you'll notice with Python, and we'll discuss that in more detail in the object-oriented section. But Python is highly polymorphic. So, and that's, you know, in general how you use Python. You don't try and constrain a variable to a specific type. What you're really interested in is a type that's going to have certain properties. And in this case, I don't care what you pass in, you know, as that second container. This function doesn't care as long as it supports the in operator. That's the only thing it needs to support. Okay, but again, we'll get to that in later sections. So if z is in the container, we're just going to pass. We're not actually going to do anything with that. Okay? All right. So let's go ahead and run some tests. So time perf counter, that's going to be our start time. Then we're going to run membership test, and we'll do that 10 million times as well. And the first one we're going to look at is the car list. Then we'll do end equals time dot perf counter, and then we will print, and we'll say that this was for the list, okay, and the timing was therefore end minus start. That will give us the number of seconds that elapsed. So let's go ahead and run that. It will take a little while to run. Well, if I membership test, helps if I spell correctly. Okay, so let's let that run. Okay, so finished running, took 5.3 seconds. So I'm going to copy this entire list, this entire chunk of code, and now instead of doing the membership test in the list, we're going to do it in the tuple. So this will be the timing for tuple, and let's run that. And 5.31. So, you know, I mean, again, this isn't the benchmark, but it's about the same, maybe a little faster, but it could be a little slower in some cases too. It's about the same. Okay. And let's go ahead and run it once more. But this time we're going to look at the set. And this will be our set. Let's run that. And as you can see, it takes half a second. So really, as you can see, a lot faster doing set membership than doing tuple or list membership. So whenever you can, prefer using set membership. All right, thanks for watching, and I'll see you in the next video.